Hello and welcome to this video about a Pythagorean theorem recap. This is not going to go into full detail about the Pythagorean theorem, more for recapping some things you've learned perhaps before and just need to kind of freshen up on. So the learning target is simply, what is it again? How do we use it? Let's just kind of refresh ourselves with all of it. Okay, so the Pythagorean theorem, there's a couple of parts to it. The first part is the actual theorem itself. And the way it works is if we have a right triangle, then we get this really famous equation, which is a squared plus b squared is equal to c squared. All right. When we plug numbers in, it will be true if we have this right triangle. All right. Now, when it comes to the right triangle, there's a couple pieces that we need to know. First of all, a and b can be swapped if we want them to. They're just the legs of this triangle. They're not the longest side. So again, we would refer to both of these as the legs of our triangle. C, this one's kind of important, so I'm going to put it in red. That one has to be the longest side, which is referred to as the hypotenuse. All right. And so again, if we're given the right triangle, if we have that little symbol, we know that we can take these values, square them, add them up, and it'll be equal to whatever this one is squared. All right. And when it comes to finding the values, the orientation of the triangle doesn't matter. Sometimes that might throw some students off. The big thing is we just have to know that the hypotenuse is always that longest side. And again, A and B could be either side. So that could be A and B. This could be B. This could be A. Those don't really matter which one's which. But C has to be the longest side. Now, what we can do is we can use the Pythagorean theorem to find missing side lengths. So let's take a look at some examples here. We want to find this hypotenuse. So what I'm going to do, and it's implied that all these are right triangles, and now I just made them right triangles. We're going to use the Pythagorean theorem. 8 squared plus 15 squared is going to equal whatever our hypotenuse is squared. All right. So now I'm going to crunch my numbers. I'll get 64 plus 225 is equal to c squared. Add these together, I get 289. Now, I recognize that as, you take the square root, that's 17. So this is equal to, oops, not c, 17. So I can use the Pythagorean theorem to find the missing hypotenuse. I can also use it to find a missing side length. But now I got to recognize that this 12, that's equal to my c. So when I go to set it up, I'll go 5 squared plus my unknown squared, so I'll use x, is equal to 12 squared. So I get 25 plus x squared is equal to 144. Now I want to solve this equation, so I'm going to subtract 25 from both sides. So 144 minus 25. That gives me x squared is equal to 119. So take the square root of both sides, and I have two options for this. I could either say that my missing side length is the square root of 119, which is totally fine, or I can use a calculator to figure out what that's going to be, and I can round it. So if I do that, I'll find that x is roughly equal to about 10.91, give or take. All right, so again, we can use it to find a missing side length rather than a hypotenuse. Final example I want to show you is when we throw some radicals in there. So here, I'm still going to try to find the hypotenuse. So I'm going to take square root of 5 squared plus 2 root 7, square that, and that's equal to x squared, whatever my hypotenuse is. Now, I want to do this just to kind of make a point here, that if we go root 5 squared, those guys cancel each other out. So that's just going to be 5. Now, the 2 root 7, this one's a little more complicated. This is 2 root 7 times 2 square root 7. So that's going to give me, let me move my 5 down a little bit. 5 plus, all right, then I'll get 4 times, and again, square root of 7 times the square root of 7 is just going to be 7. This is equal to x squared. Tidy up the left side of my equation. 5 plus 28 is equal to x squared. So x squared is equal to 33. Again, I could either say that x is equal to the square root of 33, leave it at that, or I could find out what that is as a decimal, and I'll find out that it's roughly 5.74. So I could use the Pythagorean theorem to find missing side lengths of right triangles. That's the first half of it. The second half is the converse of it. Now, the way the converse of the Pythagorean theorem works is it's the other way around. So what I'm going to do is I'm going to say if a squared plus b squared is equal to c squared, then I have a right triangle. And so more what's going to happen here is maybe we're going to be given a triangle. I'm told this is 12. I'm told this is 16. This is 20. And the question is it a right triangle? And we will know that if the Pythagorean theorem works for it. So what I'm going to do is I'm going to take these. 20 is my largest. So whatever one's the largest number, that's the one that's going to be C. So I'll take the other two, 12 squared plus 16 squared, set that equal to 20 squared. Now the thing I got to do here is I got to put a question mark. I'm wondering if this is true. If it is, it's a right triangle. If it's not a right triangle. So I get 144 plus 256 is equal to 400, question mark. If I add it up, I actually do get 400 is equal to 400. So yes, this is a right triangle. Another example. Say I have a triangle that is 2, 4, and 5. Same question. Is it a right triangle? Well, again, identified the largest one. That one's got to be C. So I will go with 2 squared plus 4 squared is equal to 5 squared. Again, with a question mark. I don't know if this is the case. This is what I'm trying to find out. So I got 4 plus 16 is equal to 25. That's 20 equals 25. That does not work, so no, it is not a right triangle. Finally, to give you one more example, we may be given just values. It might be like, hey, here's a triangle that's got side lengths of root 7, 6, and root 43. We have to figure out if this triangle would be a right triangle. This one takes a little more work to kind of figure out. Let's see here. So root 7 is my smallest number. This is my next largest number. And then my root 43, that's my largest number. And I know that because if I were to try to take the square root of 43, it's going to be between 6 and 7. Because the square root of 36 is 6, the square root of 49 is 7, and 43 is between those two. So I know it's larger than 6. So that's kind of the thought process I have for that. So since that's my largest, I set it up like I have with the other ones. Root 7 squared plus 6 squared equals the square root of 43 squared. See what happens? So here I get 7 plus 36 is equal to 43. Remember, squaring and square roots, they undo each other. All right? But I did actually have to go 6 times 6 to get 36. All right, add my numbers. I get 43 equals 43. So check. That does work. Yes, this is a right triangle. So that's the converse of the Pythagorean theorem. And so that's the Pythagorean theorem in a nutshell. The last thing I want to talk about are just a couple of loose ends, and it's what we would call some Pythagorean triples, or I just kind of simplify and call it P triples. These are numbers that are known to work. Highly recommend that you kind of commit these to memory and think of them, all kind of being on a triangle like this. 3, 4, 5. All right. If 3 and 4 are your legs, and then this is your hypotenuse, 5, that will work as that is a right triangle. And so that means that you can just cut some corners. You don't need to square everything and solve. You just know it's going to be 3, 4, and 5. 5, 12, 13. Same thing. That's a Pythagorean triple where it's just always going to work out. You don't need to crunch all the numbers. Another one would be 8, 15, and 17. That one works. A couple others that tend to pop up every now and then. 7, 24, and 25. And the last one is 9, 40, and 41. Now, there are more. There's a lot of them that are out there, but these are the more popular ones, especially the ones here on this side. Tend to see those a lot. And what you can do is if you multiply each of these by the same thing, so let's just say 5, the Pythagorean triple still holds true. So 15, 20, 25. That's still a 3, 4, 5. So if I saw a triangle that was 15 and 20, I might be like, wait a minute, that looks like a 3, 4, 5. I know this is 25 before I have to even crunch any numbers. All right, that's it. That's the Pythagorean theorem. So to a little recap, all in a nutshell. Hopefully this has helped. Good luck with your homework, and let me know if you have any questions.